Good morning, everyone. So we'll be starting with the bridge course today. Bridge course in physics. What does it mean? Let's first understand the meaning of the word bridge. So you see, when you move from 10th to 11th, there is a drastic difference in the standard of the problems and the theory that you'll be studying, right? So moving directly from 10th to 11th is quite difficult understanding the new topics that you will be coming across. But then I hope you also understand that there will be some topics in 11th and 12th that would be somewhat more related to what you have already done in 9th and 10th. There will be new topics also, but there will be topics that will be relatively more linked with what you have already done in 9th and 10th class, right? There will be a link. There will be some topics which would have links, right? So what we are going to do here in the bridge course is we are going to cover precisely those topics uh, first that already have links with what you have done in the previous junior classes, right? And once we have established that link in this bridge course, then we'll start with the actual main course which starts from June onwards, right? So that is the objective of bridge courses. That is to establish a link between what you already know in 9th and 10th, and then patching it up with what is there in 11th, doing only those topics in 11th which you already done in 9th and 10th classes. Right? So let us start with the first chapter in bridge course, which is quite trivial, and that is to do with units and dimensions. Right. And in units and dimensions, we'll be covering these topics. First of all, we'll be seeing what are physical quantities, then what are fundamental or base quantities, what is plane angle, what is solid angle, so on and so forth. So we'll first start with physical quantities. Right? And let us see what are physical quantities, and then we'll go ahead with the rest of the topic. So what is a physical quantity? Well, physical quantity is nothing new. You already know every quantity that you need to study physics is called physical quantity. So literally almost everything that you know is a physical quantity. So quantities by means of which the laws of physics are described are known as physical quantities. Now let's take some example to get a better hang of it. And the example would be like mass, right? The most basic quantity, mass. That's a physical quantity. What else? What else do we know of mass other than that? What about temperature? We have studied temperature also, right? So temperature is also physical quantity because you use mass to calculate or to find some values. You use temperature to find the temperature of some point. Then what else could be a physical quantity? Like speed, right? Or velocity, so on and so forth. And this everything almost that you know is a physical quantity, like acceleration. All these are physical quantities. What else could it be? It could be length also, right? It could be time. It could be current. So I think you're familiar with all the things, all these quantities you're already familiar with, right? So that's what I was saying. Doing those things that you're already familiar with. Okay, so there are two types of physical quantities. What are two types of physical quantities here? One is your base or fundamental quantities. And then comes your derived quantity. So there are two types of quantities. The first type base and second type which is derived, right? And what is the difference between the two quantities? You'll be seeing that in the impending slides. So let us start with derived because it's easier to understand base once you understand derived quantities, right? If you want to take this down, I'll hold on for a minute. Okay, so let us see what are derived quantities first, right? It's easier to make sense once you know what are derived quantities. Then we'll go to fundamental or base quantities. Derived, right? So, or let me not tell you what is derived and what is not. You can make it out yourself. You see, let's say speed. Speed is what basically length upon time, right? Now, see, speed is made up of length and time, right? So you can't define speed without length and time. And length and time are taken as which quantities? These are taken as base quantities. So what does that make the speed? So speed naturally becomes, see, speed is dependent upon these two quantities. Which quantities? Length and time. Speed is dependent on those two quantities, right? So since it is dependent on those two quantities, speed will inevitably become which quantity? It will become a derived. Why it is derived quantity? Because it is literally getting derived from what? From length and time. It's literally getting derived from length and time. Right? So let us see what are base quantities. There are a list of base quantities. So let's go through them. So base quantities are, these are treated as independent quantities, independent of the other physical quantities. The units for these quantities are called fundamental or base units. And then there are 7 base units that are described here. So let's go through them one by one. Length, as you already know. Uh, what is the base unit for length? Base SI unit for length is what? So there is centimeter is there, then kilometer is there, meter is there. What is the SI unit? But SI unit is meter. And the unit symbol is M. Similarly, what about mass? Mass also, you know, is gram. The unit can be either gram or kg or ton. But what is the standard unit? Standard unit is kilogram. And what is the symbol? Kg. Right? What about time? Time also, you know, has got so many units, right? But which is the fundamental unit? It is second. And what is the unit? Yes. What about current? It is ampere. And the symbol is A. Thermodynamic temperature? Kelvin. And the unit is, symbol is K. Amount of substance? That's mole. You must have done in chemistry. And now there's one more quantity which is called luminous intensity. That's something with the intensity of light. We don't have this in our syllabus, right? So we don't have to worry much about it. So, and you have not studied also about it. Neither will be using it in 11th and 12th anyway, so don't worry about it. The unit, but the unit is candela and represented by the symbol CD. Right? So you can take a note of this, and then we'll move ahead. Okay, then along with these base units, we have got some supplementary units also. So what are supplementary units? There are 2 supplementary units. One is plane angle and the other is solid angle. Now there is a stark difference between what is plane angle and what is solid angle. There is a difference between them, but we'll not be exploring the solid angle as of now in detail. We'll be studying this in 12th class. Right? I'll just give you a formula, that to a formula in a very special case. But if you want to study, really understand solid angle, that will be covered in the 12th class. Plane angle, yes, plane angle, you have been using whatever angles that you know till now are plane angles, right? So there's nothing new about plane angle. Plane angle unit is, now you might think it is degree, right? Because that's what you have been using it in the junior classes, but actually it's the standard unit is not degree, it is radian, represented by rad, and solid angle unit is radian. Represented by SR. So let's check what plane angle is. You can take this down. Fine. So let's go ahead. Let us see what is plane angle. So plane angle, what you have been studying is plane angle. You know, you draw two lines, they intersect somewhere, and the angle between them is represented as theta, and that's the plane angle. So what are plane angle? It is the angle formed between two lines, right? And is it sufficient to say two lines, or do I need to mention something else also along with that? If I just say two lines, you see, there could be a problem, because if you just draw two lines, if they are parallel lines, you won't be able to find the angles. So it is also mandatory to mention that the two lines should be intersecting. So two intersecting lines. So if you have two intersecting lines, the angle formed between them is called plane angle. Represented by theta. These lines are contained in a what? So you can see that these two lines, 1 and 2, they are intersecting here, and those two lines are confined in this one plane. Can you see in this plane? Plane of what? This is a plane of both. So likewise, if you draw it in your copy, it will be contained where? It will be contained in the plane of your copy or the plane of your page. So these lines are contained in a plane. And now you must have guessed it. That is why we call what angle? We call it plane angle. Right? The plane name comes from here. Hence the angle thus formed are called plane angle. And now you must have guessed it if you remember I told you about solid angle, did it? Right? I told you about solid angle also. Now solid angle in stark contrast to plane angle cannot be contained in a plane, right? And that is why it is called solid angle, because you can't put it in a two-dimensional plane. It actually goes in three dimensions, right? And how does it manifest exactly? We will be seeing it in detail in the probably the main course, but not entirely. Uh, we'll be seeing it in extreme detail in 12th class. You will be using that to prove the Gauss theorem using the Coulomb's law. Gauss theorem in a special case for static field. Okay, now since I told you what are plane angles, let us see the formulas pertaining plane angles. You see, if I connect these two by an arc here, and what is this? If you see, this is the radius, right? Now in the junior classes, I suppose you would know the relation between them also. This is the arc length represented by the letter L, and the radius represented by the letter R. That's a theta. So you know what is the relation between theta, R and L? Theta is equal to L upon R. That's what we have in the next slide as well. So you can see here, this is your theta, right? And this is your arc length. That is your angle or plane angle to be precise. This is your radius, right? And as I told you, the formula is theta is equal to L upon R. So that's the relation between the angle, the plate angle, and the R length and the radius. Now, which is the standard unit of angle? Standard unit. Standard unit is, as I already alluded to, radian and not degrees, right? So don't come up with degree, because I know you kids are accustomed to using degrees in your junior classes. Uh, but now you have to understand that the standard angle, the standard unit is not degrees. Like the standard unit for length is not centimeter, right? You know it's meter. Right? So likewise, you have to be wary about the standard unit. In this case, it is radian. Okay. So standard unit of angle, already mentioned, it's radian. Relation between degrees and radius. So let's see the relation. So now you know what is degree, and I told you the standard unit today. I told you it's radian, right? So you would be intrigued to know, after all, what is the relation between degrees and radius. Let's find that out. So for that, we'll use something that you kids already know about, and then we'll work upon it from there. Like if you draw a line like so, I mean two lines, they're intersecting at this very point, right? So what is the angle between them kids? This angle, as you have been told, it is 180 degrees, right? That you already know. So what I'm going to tell you here is, this is actually equal to, it's also equal to pi radian. Right? So that is how degrees and radians are connected. 180 degree is defined as pi radian. Right? So now from here, you are free to find out relation between degrees and radians, howsoever you may deem fit. Like if you wanted to find out the value of 1 degree, so you can see what is 1 degree. So 180 degree can be written as what, kids? 180 into 1 degree is equal to pi radian, right? And let's say you wanted to find out the value of this, the value of 1 degree. What will it be? 1 degree will be what? Well, it will be pi divided by 180 radian. Right? So that's essentially RD. You see, is a short form for radian, right? So I just use RD. So 1 degree is equal to pi by 180 radian, right? So that's how you find the relation between degrees and radians. 1 degree is equal to pi radian upon 180. What if you wanted to find out the value of 1 radian? That would also be required in the future, right? So how would you find that out? Let's do that also. That's quite straightforward from here. So 1 radian is what? 1 radian is, so instead of bringing 180 to the other side, what we'll do, we'll instead take pi to the other side. So it will essentially become 180 degree divided by pi. So 1 radian is equal to 180 degrees upon pi. And you could also go ahead and divide that to find its exact value. That will be 180 degree divided by pi. And pi, as you know, is around 3.14. That will give you, I think, 57.3. 57.3 degrees. So 1 radian is actually equal to 57.3 degrees. Okay, so now let us see what if theta is what if L is equal to R. That will be, what will be the value of, what is theta if L equals to R. Now you can think about it. I have already told you the formula. Theta is equal to L upon R, and I want you to find out what will be the value of theta if L is equal to R, right? So let me see who can tell me. If L is equal to R, you put the values there. It's R upon R. The value of L is R. That turns out to be 1. But now the $1,000,000 question is that that will be 1 watt, right? 1 watt exactly. So you would be quite inclined to say it will be 1 degree because that's what has been taught to you. But as I have been intoning, it is the standard unit is not degree, it is radian, right? So this is essentially 1 radian, right? And as you know, 1 radian is also amounts to 57.3. That's what theta comes out to be when L is equal to R, right? So let's take down the last part, which is total angle about a point. Let's check this out. Total angle about a point is what? Let me see how many of you kids can guess it. So if you take a point here, right, what is this total angle? As you have already studied it is 360 degrees, right? Now 360 degree is essentially twice of 180 degrees, right? And what about this 180 degrees? Well, that is equal to pi radian, right? So that's 2 pi radian. So we get that 360 degrees is equal to 2 pi radian is the total angle about a point. See, when I say angle, it is implied that I'm talking about plane angle, right, and not solid angle. When I have to say solid angle, I will be specific about it, and when I am not, it is by default plane angle. The total plane angle, of course, about a point is 360 degrees or 2 pi degrees, right? So you can take down the important point for moving forward. Right, so let's go ahead here. Now, plane angle unit conversion. So, you have only studied one unit, that is You've already studied degrees, right? Now there's something called arc minute also. And arc minute is represented by a dash, right? So 1 degree is equal to 60 arc minutes. So you can say that 1 degree is equal to 60 arc, right? So that makes 1 minute how much? 1 minute we see, when I say 1 minute, it is 1 arc minute, right? So I will not be repeating, or generally the books also, they don't repeat the word arc over and over again, even though it's supposed to be there, right? Because minute is, the unit of time. It's actually arc minute, but in short, we'll just write it as minute. So keep that in mind. Now, 1 minute can also be written as what? How many radians it is asking. So 1 minute is how many radians. So let us see how do we find out 1 minute is how many radians. Let's try to figure that out. And you can also try to calculate it. It's a trivial problem. So we know that 1 degree is equal to 60 minutes, right? That's given to us. From there we have to find out what is 1 minute. 1 minute is equal to how much? 1 arc minute is equal to how much? How much what? How much radian? Right. So let's see how we get to that. So this can be written as 1 degree is equal to 60 times 1 minute, right? 1 minute comes out to what is 1 degree upon 60, right? But then we're still not there because we wanted in terms of radians, right? And what have we achieved here? Well, it's only we have reached degrees, right? We got to go ahead with this and get the value of 1 degree in terms of what? You see, we need to establish a relation between minutes and radians, right? What have we achieved till now? We have achieved 1 minute and degrees relation, right? We got to go further from here. So 1 degree is what? If you remember, we did find out what is 1 degree equal to, didn't we? Here it is. That's what 1 degree is equal to. It is pi radian divided by 160. We could very much use that formula that we have already established. Use this and find the relation between minute and radian. So see, 1 degree is pi radians upon 180. Pi radians upon 180. And then we have equals to, well, I've written the value of 1 degree, kids, right? 1 degree is done. But do you see that there is one term, Mr. 60, dangling here, right? You got to use that also. There. And that is what your 1 minute is equal to. All we have to do is simplify it and you'll get what is 1 minute is equal to in terms of degrees, right? So let's do that. And you have to solve this yourself by hand, but I'll just be doing it by calculator. You kids have to know how to do it by hand. Uh, approximate value of pi is 3.14 divided by 180. So this is a numerical calculation that you have to do. Do it and tell me how much is you're getting. So I'm getting around 2.91 into 10 raised to the power minus 4 radian upon calculator. So that's 1 minute equal to, or as it is said, 1 arc minute. Now let us find the relation between. So what did we study here? What did we come to know about? What is the new term we learned here? What is the new term, kids, that we learned? The new term that we came across here is arc minute, right? We didn't know this before. We knew degree, but we didn't know arc minute. I gave you a relation between what is 1 arc minute, how is it related to 1 degree. So now what I'm going to do is, I'm also going to check what is 1 arc second, right? Like we studied 1 arc minute, let us also see what is 1 arc second and write a relation with them. So it so happens the way it is defined tells us that 1 arc minute is actually equal to 60 arc seconds. And arc second is represented by what, kids? By which symbol? Arc second is represented by this double prime, double dash, where single dash was used to denote what? Single dash was used to denote arc minute. For arc second, we use double dash. Okay. So let me write that 1 arc minute. And if you can remember, for minute we use 1 dash, and that happens to be equal to 60. 60 double dash implying 60 arc seconds. Okay, so now see, we have a new unit at our disposal. Which unit is that? It is arc second. This quantity is a new quantity, arc second. So what can 1 arc second can be written as what? How many radians we have to find out, right? So that's the new task we have at hand, and that is like here. What was the task, kids? Before this, the task was to find relation between minute and radian, right? Which we successfully did. And now the next objective will be to find the relation between second and radian, right? Second and radian, that's going to be our secondary objective. So let's do that also. So let's see what's the relation between second and radian. So starting from what we already have, we have 1 second is equal, sorry, 1 minute is equal to 60 seconds. So first of all, what we'll do is we will write what is 1 second equal to. 1 second will be what? 1 minute divided by 60. And why did we do that? Because I'm trying to play smart, as I already know the value of 1 minute. We did it in the last problem, right? And what did 1 minute come out to be? 1 minute came out to be this object, pi by 180 radians divided by 60. So we can use the same formula here, same relation here. Pi radian divided by 180 equal 60. And then of course you have a division with this object which is left over 60, and that comes here a further 60. Okay? And then again doing the trivial numerical jugglery, you should be able to find the relation. So that comes out to be there. So you can have to do this calculation by hand. Pi is 3.14, and that roughly comes out to be how much? Check it. It in the exam, you guys don't use calculator, you do it by hand and check if you're getting the same value or not. So I think we're pretty much done with this topic as well. So 1 second comes out to be 4.85 into 10 raised to the power minus 60. And 1 degree is equal to how many seconds? That also you should be able to tell me now. So we know that 1 degree is equal to what? 60 minutes. Which can also be written as 60 into 1 minute. And Mr. 1 minute can be written as what, kids? Further as 60 seconds, right? Or that is as 60 seconds. And that should give me 3600 seconds. That's 1 degree. Got it. So I think we have developed all the necessary relations, and now you kids should be knowing what is the relation between degrees and minutes and seconds, arc seconds and arc minutes, of course, to be precise. So you can take this down and move to the next slide. So let's go ahead, kids. Let's go to the next slide. Let's see what we have. So we have a problem here. based on what we have studied, right? So this will be quite a natural way to conclude today's lecture by doing this problem. So I would give you some time for you kids to try on yourself by yourself and see what you're getting. We don't have much time. It's around 3 to 4 minutes now. We'll end it shortly. Try doing this problem. What is the length of the arc? So as we know, theta is equal to L upon R is the formula we studied, and what was L there? It was arc length. What was R here? It was the radius. So theta is equal to L upon R. And they're asking what is the length of the arc. So basically they're asking the value of L. So what is L coming out to be? R theta. It's coming out to be R theta. So what is R here? As you can see, it's 1 meter. A2. What is theta here? Theta is the angle. Is how much is? Well, that is pi by 6. And you see, they just mentioned pi by 6, but we know that actually should have been the unit should have been there. Let's say given it's radius is the pi by 6. When pi is there, of course, it implies that they have given in terms of radius. So it's actually pi by 6. And then what is length? What indeed? It is pi by 6 meter. Right? And the value of pi, as you know, is 3.14. 3.14 by 6 meter. And again, do the calculation. Let's see what option you're getting. Check it for yourself. It come out to be 52.3 centimeter, right? But see, I'll tell you a fast way of doing the calculation, because in the exam you will not be always be able to do the precise exact calculation. You don't even need to do exact calculation, guys. Why? Because you have options here, right? So you can try doing a crude calculation and still get a idea of what answer should it be. If you were to do it that way, let's do it. Ideally, you should always do the actual calculation, but if you're running short on time and you have to simply guess the option, so what you can do is, see, 3 and 3.14 can almost be taken as what? We're going to, as I already alluded to, we're going as crude as possible. 3.14 can almost be taken as 6, right? 6 by 3 by 6 meters, that goes on. That's like 0.5 meters, and which is essentially 50 centimeter, right? At 50 centimeter, which option is closest to it? Well, that is a D. But that is only if you're running short on time, and the options are quite far apart. You see. Now, if there was another option, you would be in a fix. If there was some other option called, let's say there was an E option saying 50 centimeter, right? Then you wouldn't know what to do, because 50 or let's say 51 centimeter, something like that, right? So then you would be in a difficult position there to decide which option is correct, and then you'll have to do the actual calculation. Okay? So that's pretty much for today, and we'll start with we'll do some more problems next time. Okay? So see you kids in the next class.